When an acidic substance or an acid is dissolved in water, the hydronium concentration will increase. Values could range from just 10 to the 0 molar to just above 10 to the minus 7th molar hydronium, right? Here's the concentrations here. So we have a chart. Here's the concentration of the hydronium ion. Very acidic, you're up here, decreasing acidity until you're neutral at 10 to the minus 7th. Increasing acidity goes this way. So your water ionization constant, the hydronium goes up. That means the hydroxide goes down, the concentration, but the product is still 1 times 10 to the minus 14th. If a basic substance is dissolved in water, the hydroxide concentration will increase. Values can range from 10 to the 0 molar, another way of saying 1, to just above 10 to the minus 7th molar for the OH concentration. So we have a chart here. We have the concentration of the OH minus ion, and you're very basic at 10 to the 0. You decrease your basicity until you're neutral at 10 to the minus 7th. So here's our ionic constant of water, which we know is always 1 times 10 to the minus 14th. So if you increase the hydroxide, you decrease the hydronium because their product must remain constant. Example 1. Add some hydrogen cyanide to water. So it disassociates here to some degree, and the concentration of the hydronium ion in aqueous solution is 2.3 times 10 to the minus 6th molar at 25 degrees Celsius. Now recall, pure water has a concentration of hydronium of 1 times 10 to the minus 7th. So the hydronium ion concentration here is greater than this number, right? 10 to the minus 6th greater than 10 to the minus 7th. So this solution is more acidic than pure water. We'll talk about how we measure this later on. This time we'll add some solid sodium hydroxide to the water, and then it forms aqueous sodium hydroxide as it dissociates. And this time we find that the hydronium concentration, because that's what we're measuring, the hydronium ion, is 4.1 times 10 to the minus 11th. We use the ionic constant of water and we calculate this right here. And how did we get the hydroxide concentration? Well, that would be the ionic constant of water divided by the concentration of the hydronium ion. Okay, we did some problems like that earlier. Now we note that this number is greater than 1 times 10 to the minus 7th molar for hydroxide in a neutral solution. So this solution is basic.